Okay, welcome back to day one of our solving polynomial equations. We are finishing up factoring example 2b. Again, we did our synthetic division to find that x plus 2 is a factor. And now what I have left is a quadratic. And if I were to set up my x method here, I would get 2 times 6, which is 12 in the top, negative 7 in the bottom. My two magic numbers that multiply to 12 and add to negative 7 are negative 3 and negative 4. I need to divide by a. Negative 3 will not evenly divide, but negative 4 will. So I have x plus 2, x minus 3 halves, and x minus 2. I'm almost done. I just need to clear this fraction here by multiplying my denominator. So that one would become 2x minus 3 and x minus 2. And now I have factored completely. So that is how you use your rational root theorem to factor, but what does that mean for solving? Well, once you would get to this step, you would do what we have done when we solved by factoring with quadratics. You would set each factor equal to 0, and this time you're going to end up with more than 2 solutions. So again, the number of solutions is going to be the same as your degree of your polynomial. So if you have a degree of 4, you're going to have 4 solutions. If you have a degree of 3, you'll have 3 solutions. So we're going to use the rational root theorem to factor until we get a quadratic. If we can factor the quadratic, that's great. We will factor that last bit. If we can't, we're going to have to use the quadratic formula or completing the square to get our last 2 solutions because they might not be whole numbers. We might have something with a non-perfect square inside of a radical, or we might even end up with an imaginary solution. So let's jump back into it here on example 3a. The first thing we need to do is find all of our possible rational roots. So Q is 1, and P is 30. So if I go to state all of my possible factors of Q, that's just going to be plus or minus 1. And then all of my possible factors of P, again, they're all going to be plus or minus, but we have quite a bit here. We're going to have 1, 2, 3, 5, 6, 10, 15, and 30, which means all of these possible P over Q values are going to be plus or minus 1, plus or minus 2, plus or minus 3, 5, 6, 10, 15, and 30. Whew, okay, so that's a lot to test out. So let's just go in the same order we have been going and see about x plus 1. Let's try x plus 1. I'm going to go back to my scratch paper here. And again, we're dividing x cubed plus x squared plus 4x plus 30. And the first thing we are going to try is x plus 1. And I get a remainder that is not 0, so that one is not a factor. So now I'm going to try x minus 1. And for the sake of time, I'm going to pause to write down the work and just show it on screen. Okay, here is my synthetic division trying x minus 1. That one is also not a factor. So I'm going to move on to 2, trying x plus 2, and I'm going to do the same thing. Okay, here's my work for dividing x plus 2. I got a remainder that is not 0, so this one is also not a factor. So now I am going to try x minus 2. Here's my work for trying x minus 2. Again, I got a remainder that's not 0, so that one is also not a factor. So now I'm going to try x plus 3. And 5th time is the charm here because I did get a remainder of 3. So if I were to factor out x plus 3, I would get x squared minus 2x plus 10 as a result. So again, I have x plus 3 and then x squared minus 2x plus 10. Now, this one cannot be factored. I do not have factors of 10 that add to negative 2. So what I'm going to have to do to find my remaining 2 solutions is solve by some other method. So again, that can be quadratic formula, that can be completing the square. But what I am going to do now, and I'm going to do this work on scratch paper, is set each of those 2 factors equal to 0. So if x plus 3 equals 0. That one's easy. You just move the 3 over, and we have negative 3 as one of our solutions. But for the other one, x squared minus 2x plus 10, again, you can do quadratic formula, you can do completing the square. I'm going to do this one by completing the square, so I'm going to move the 10 over. And then the value that completes this square is going to be 1, so I'm going to add that to both sides. So this is x minus 1 squared equals negative 9. So I'm going to square root both sides, and x minus 1 is going to be, this will give me an imaginary solution, plus or minus 3i. So moving the 1 over for my final step, I'm going to have 1 plus 3i and 1 minus 3i as my other two solutions. So I had one real solution and two imaginary solutions here. So my three final answers, negative 3, and then 1 plus 3i and 1 minus 3i. And I know that 3 solutions is the correct amount because I had a degree of 3 for this polynomial. Okay, and we are going to repeat that process again here for b. Again, my q value is 1. My p value is 13. And now this one's going to have far fewer possibilities because q can only be plus or minus 1 and p can only be plus or minus 13, which means p over q can only be plus or minus 13. So let's try x plus 13 first. Again, I'm going to pause to do the work for this on my scratch paper. And here's my work for dividing x plus 13. Got a really large remainder, so this one is definitely not a factor. So now let's try x minus 13. Again, I'm going to pause to do that scratch work. Okay, and there is that scratch work for dividing x minus 13. I got a remainder of 0, so this one is a factor. And when I factor out x minus 13, what that left me with was x squared minus 1. So this is one that I can factor further because this is a difference of two squares. So I've got x minus 13 and then x plus 1 and x minus 1. This one was able to be factored completely, so I can set each of those factors equal to 0 to get my 3 solutions, and they will all be real this time. Those solutions are going to be positive 13, negative 1, and positive 1. I know I should have 3 solutions because this was a degree 3 polynomial. Okay, we are going to move on now to, this should be C and D, and these are both degree 4. So we're going to be looking for 4 solutions here. I'm going to start on C. Again, my Q value is 1 and P is 12. So Q can only be plus or minus 1, but P can be plus or minus, again, 1, 2, 3, 4, 6, and 12. So all of our P over Q values are going to be plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, and 12. So let's go through and we are going to try x plus 1 for our first. And again, I'm going to pause to do this scratch work. Here is my scratch work. I got a remainder of 0 on the first try, so that one did work. So when I factor out x plus 1, what I have left here is x cubed minus 3x squared minus 4x plus 12. And now this one is not a quadratic yet. It's not a degree 2 that I have left, so I can't do any of my other methods yet. I'm going to have to do the rational root theorem again, looking at my second factor. So here, this one has a value of q of 1 and a p-value that is also 12. So what that means is my possible rational roots are going to be the same. So let's go through and try a few. I'm going to start with x plus 1, and I'll show you the work for that. But recall, we are now dividing x cubed minus 3x squared minus 4x plus 12, not our original polynomial. Okay, here is my work. I got a remainder that's not 0, so that one is not a factor. So I am going to move on to x minus 1. Okay, that one is also not a factor. So I'm going to now try x plus 2. And that was successful. I did get a remainder of 0. So what this means is, again, I first started with x plus 1. Now I have factored x plus 2, and what I have left over from my synthetic division is x squared minus 5x plus 6. I have a quadratic, which is what we're hoping for and looking for, and this one can be factored. Numbers that multiply to 6 and add to 5 are -2 and -3. I don't need to divide because a is 1, so this completely factored is going to be x plus 1, x plus 2, x minus 2, and x minus 3. So to get my 4 factors, my 4 solutions, excuse me, I'm going to set each of those equal to 0. And this one will also have all real solutions. We're going to get -1, -2, +2, and 3. And I know that 4 solutions is the correct outcome because we started with a degree 4 polynomial. Okay, we have one more to go, so I'm going to record it in a third part, and it should be quite short.